Hey everyone, today we are joined by Michael. He's on the interoperability team here at Avalanche, and we're going to talk about Teleporter and how we can send messages from one EVM chain to another. Hi Michael, thanks a lot for joining us.
Of course, thanks for having me, Martin.
Nice. So the first question is kind of like to understand the data flow of a cross subnet message sent with Teleporter. Maybe you can tell us a little bit like what happens exactly on what chain and how does the message get from one chain to the other with Teleporter?
Yeah, absolutely. So I guess to start off, Teleporter is a EVM to EVM cross-chain messaging protocol built on top of warp messaging, which I know you already have gotten into a good extent. I think the main way that we think about Teleporter is that it enables easy development on top of warp messaging within the EVM, such that any Solidity developer, smart contract developer can just call the Teleporter contract to send a message to another subnet within Avalanche. And that message will then be received by Teleporter on the destination side subnet. As far as your question is what the data flow is, it's there are a lot of steps under the hood there that happen sequentially. So the first thing is on the source chain. You can think of this as a bridge example or really any cross-chain application, but let's go for a bridge for sake of simplicity and familiarity. So a dApp would call Teleporter on the source chain and say, send this message to address XYZ on chain ABC. That call to the Teleporter contract is called send cross-chain message. It has some additional information like the amount of gas that needs to be provided on the destination chain in order to execute the message, the fee that's associated with delivering the message and whatnot. When the dApp, which would be the bridge contract, calls Teleporter, Teleporter in turn calls the warp precompile to emit an event that allows the validators of the source chain to know that they should be willing to sign that message, whatever it may be. Once that transaction is included in a block and accepted on the source chain, all of the validators of the source chain are then willing to provide their BLS signature of that message, at which point the AWM relayer, which we can get into, picks up on that message, on the warp message, and queries the source chain validators for their BLS signatures, aggregates them into a single signature, and then broadcasts the message as well as the aggregate signature in a transaction that the relayer sends on the destination chain. So when that transaction reaches the destination chain, then when it gets accepted in the block and when it's being executed, the aggregate signature gets validated to make sure it represents sufficient stake weight of the source chain. That's all abstracted away at the warp level with the warp precompile. But the Teleporter messenger contract on the destination is called, which then passes the message along to the ultimate destination contract, which we're getting back to now. The bridge example would Teleporter would call that contract with the message bytes that has already been fully verified, and that contract would then handle the bytes however it may do so. That's up to the application to define. In the case of a bridge contract, it would mint some representative token on the destination chain.
Awesome. So yeah, we heard already there are a lot of steps that are happening. But what would you say, like, which of these elements are abstracted away from the developer? So what do they actually have to take care of, and what just kind of like rolls within Teleporter without even knowing really what happened?
Yeah. So the way we tried to design and build it was that as much as possible is abstracted away under the hood. Of course, it's fully transparent if you want to go look at it. But as far as dApp developers are concerned, all they should need to do is call Teleporter to send a message on the source chain. So that's one additional call from your Solidity contract on the source chain, calling out to the Teleporter messenger, which is just another Solidity contract on that chain. And then on the destination chain, you just need to implement the handling of that message when it's delivered by Teleporter. So the very first and the very last step, right? We kind of walked through how teleporter calls the warp precompile, and then there's a relayer, and then it's delivered to teleporter on the destination chain, goes through this verification. That's all abstracted away. All you need to do is call teleporter, send cross-chain message, and then implement the method that teleporter will call on the destination, which is receive cross-chain message, or receive teleporter message, sorry. And you get to define how you want to handle that message. In the example of the bridge, you'd be receiving the messages you sent, and then handle it by minting the representative token. But it's really the only logic you need is calling send and then handling receive for implementing however you want your messages to be handled in the context of your specific application.
Awesome. So then on the destination chain, the message is literally just a parameter of the function that I implement. And I just, it's kind of like an event listener if you come from the JavaScript world, right?
Yeah, absolutely. So the message is delivered as really just raw bytes in Solidity. That it's the bytes type, and there's a world of possibilities within that bytes type, I guess, because you get to encode whatever messages you would like to encode. And we have a few example applications that do this, and we just use ABI encoding to define the struct of a message that an application wants to send, and then you can use the ABI encode method on the source chain, ABI decode on the destination chain, and then know all of your data types and the values within that message. But the message itself is just raw bytes. Yeah.
Awesome. So basically, I can take these two functions to put whatever variable I have of whatever type, convert it to bytes, send it over with teleporter, and then unpack it on the destination chain and convert it to whatever type I need. Let it be a string, a number, or a combination of these, right?
Exactly.
Awesome. Cool. Yeah, that doesn't sound too hard. So then let's get to it and build our first smart contract, sending a simple message between two blockchains on the Avalanche network. Thanks a lot, Michael, for joining us, and we will see you in the next lecture.
Awesome. Thanks, Martin.